All right, guys, let's dive in. So today we're talking about terminating decimals. Who gets my joke up there? My bad joke? Yeah, Dom, why is that a bad joke?
Because it's referring to the Terminator.
The Terminator. Now, why is the Terminator all the more interesting?
Because he's like a robot. He's really cool.
Yeah, who played the Terminator? Yeah,
Oh,
who was the actor?
Arnold Schwarzenegger.
Arnold Schwarzenegger. What else did he go on to do?
Everything else.
Steroids?
No, I don't think so. I think those muscles are all his.
I don't
Sean?
know. He went on to like lifting or competition.
Okay, so he wins a bunch of weightlifting competitions, and he has a big weightlifting competition here in Columbus. But why else is he interesting, Saul?
He's a mayor. And
Not mayor, governor of California.
Also,
So he also, his nickname is the Governator because he was the Terminator, then became the governor. But we are going to start by diving into 6-1 right at the end there where we had left to compare these values. And then we will go into 6-2.
What's a minute? I'm confused.
Just our launch. So our learning target once we get into 6-2, just so I don't forget it and skip it. So we want to make sure that we can perform the division between any rational values, be them integers or fractions. And then we can determine if it's going to produce a repeating or a terminating decimal. Now, how yesterday did we determine it was going to be repeating? What is it that we see? And it's a question on your test. How do we know that my decimal expansion is going to end up repeating? Monica?
Because we find a pattern in the remainder of the division.
Yeah, the remainder values from the division. I still have them, so I was passing out. I'm just throwing in. Anyone else need the 6-2 notes? I've gotten almost everybody. Okay, remember extras are up here in the little bin standing up to the side. So, as Monica said, we see it's going to repeat when we see a pattern happen in the division. And guys, if you use your notes on last night's homework, who got like 100% or very close on the first try? Yeah, if you used your notes last night, it should have been real easy. So if you needed to make that second attempt, hopefully you pulled out your notes and then realized that makes life easier. So we have a special effects crew. And if you've ever seen Raiders of the Lost Ark or any of these older movies, these special effects were really tough to do because we didn't have all the CGI and all the technology that we have today. So we've got this plane, and it's a model plane. They're not going to fly the real one through there. But it's 8 7/12 inches wide from wingtip to wingtip. And the tunnel it needs to fly through is 8.7 inches. Well, why do you say it's going to blow up, Jeremiah?
Is 8 and 7/12 bigger than 8.7 inches?
Are you asking or are you telling me?
Wait, no, it's big enough.
Okay, so you still haven't explained anything.
No.
You're thinking to yourself. Think out loud.
If you divide, if you do 12 divided by 7, I know it's
Ooh,
not,
hold up. 12 divided by 7.
because I know you can't, it's gonna be a decimal, but still, it's gonna be smaller than
You said it backwards.
7 divided by 12.
7 divided by 12.
It's gonna be
So,
smaller than
what
12.
Jeremiah is talking about is 7 divided by 12. How do I remember which goes on the inside and which goes on the outside? Moms?
If you're taking a fraction to divide, the number on the top goes on the inside. Or the first number if you read it out, the first number that you say goes on the inside.
Yeah. My numerator goes inside. My denominator goes outside. So that numerator can help you remember. So when we look at this, obviously 12 will not go into 7, so we need to add a bunch of zeros. I would write this out on your paper just to remind you, since we didn't write out many of the long divisions yesterday. 12 into 70. How many 12s there? Well, 4 of them would be 48. 5 of them would be 60. Oh, we're too close. So we get 5 of them. My remainder would then be 10. Drop your 0. Make your 100. How many 12s in 100? By the way, I just realized that I totally steamrolled past this. Big surprise. This is Dr. Catherine Chellis, and this is Don Taylor. They both work over at the Worthington Education Center. You know how Mrs. Cullinan and myself were out occasionally for these meetings? We were out like a week or two ago. So these meetings we're taking a class about blended learning, how we use Schoology and all that stuff that we do together. So they're here just getting some footage for the district. So act like they don't exist. Okay? So you're used to cameras and things going all the time anyway, so just act like they don't exist. So we get our 100. How many 12s in 100? We are not yet that awake, so it looks like I'm going to have to start getting some volunteers from. Oh, Sean, you were on the top of the deck anyways. 8, right? How many does that give me then?
96, and then you have 4 of them.
96. So I get a remainder of 4. I drop down another 0. Flynn, how many 12s in 40?
Can you repeat that?
How many 12s go into 40? So you can count up by 12s if you need. 12, 24, 36.
So 2.
3. We can fit in that 36, but we can't fit in any more. So 36 then gives me a remainder. Sorry that I'm writing on the text, and if you're watching the video, you will not be able to see this at this point. Samantha, do you recognize anything there? Now that we got our remainder of 100, then a remainder of 40, then a remainder of 4, well, remainder of 4, then drop to 0, then a remainder of 4, drop to 0. How many 12s would fit into this 40? 3. So if I take that 36 away, I get another remainder of 4. If I zoom this out so you guys can see my division a little bit easier. Maybe. Won't scroll. There's nowhere good for me to place this. But what do we notice that we see right down here? The top part doesn't matter now. What do we notice?
It's a never-ending decimal.
Yeah, we've gotten the same, what is it? The same, those leftover values? Remainder. So that remainder value is showing me a pattern. So that then tells me that right up here, those values I get out of that pattern are going to repeat on forever. Because we've seen that happen 3 times in a row, we know it can't change. It's stuck in this loop. So that identifies. So now if we come back to the original question that Jeremiah was grappling with. Can the plane fit through the tunnel? Now all we did was look at the fraction value of the 7/12. So what that means is this plane's width is actually 8 and this as its decimal value. Which value's bigger? The 8.7 or the 8 and 7/12? Noah, what do you think? Which one's bigger?
The hole because it's about 2 inches bigger.
Yeah, if we compare 7/10 to 58 hundredths or 583 thousandths or however far we want to go, 7/10 is wider. So just barely, but the plane can fit. So to answer the question really, yes, the plane will fit. Yeah, Andrew?
Probably crash because it's only 2 inches of space.
Actually, that's not even 2 inches.
It's 1.
It's literally 0.12, like not even, but it's 0.12, about 12 hundredths of a foot. So you'd have to figure out what 12 hundredths of a foot was.
Might be able to do it. That's like
Or no, sorry, that'd be 12 hundredths of an inch. So a little bit, yeah, little tiny space left over.
just right.
And then guys, the same process would happen here. We just want to compare the 6.4 and the 6 and 5/12. So try this on your own. You want to do the division of 5 divided by 12. Remembering that your numerator goes on the inside. Then I'm going to ask for a volunteer to come and explain this. I know, but that's what's great about the cards. Now remember, you can pass, but Julian, are you able to explain to us, either by coming up to the board or from where you are, how you work through this process?
Well, first thing I did was 12 divided by 5.
I disagree. I agree with probably what you did. I disagree with how you said it. If I read this either from top down or if I set it up horizontally, it's not 12 divided by 5. It's the other way around.
Oh, crap.
So hold on, Julian, check your work. Did you set it up with 5 on the inside and 12 on the outside?
Yeah.
Then you did it right.
Okay.
You just set it backwards. So remember, the numerator goes inside.
Oh, okay.
But you still have to say it 5 divided by 12. You read it like from the inside out.
Okay.
So I know 12 can't go into 5. I drop a bunch of zeros. So then what'd you do?
So then, I did how many times 12 can go into 50?
How many is that?
4.
Now I got to make sure I put a 0 in my decimal up top. Make sure we don't forget that just at some point. I have a remainder of 2.
Then you bring down the 0.
Yeah, we drop a 0.
And then 12 can go into 21 times.
Sorry, I think I hear someone mumbling. It's actually this 0 that gets dropped down. Goes into this 1 time. Gives me a remainder of
12. Or 8.
There we go. And we drop another 0.
And then it can go into that 6 times.
Yep. How many does that give me?
72.
Yep.
And that's 8 again. And you bring down the 0 again. And it's just 6 repeating.
Ah, how do you know that?
Because it'll, you bring down the 0 and it makes 80 again. So 12 can go into 86 times.
We get the same value up here.
Yeah. So
If I keep going, which is why I moved over to the smartboard screen, I'll get 8 again and again and again to infinity. So we see that that remainder has started repeating. Now it doesn't have to be the same number. Somebody asked me this question about well, it didn't repeat the number. I said, does it repeat a pattern? So don't get stuck in that it has to just repeat one number. Like right here, yeah, it's going to repeat the 6 out forever. But it could repeat a pattern of numbers. Who remembers an example yesterday where we repeated a pattern of numbers? Elena?
Like for the 7 one.
Okay, what do you remember how the sevenths worked? Actually, I'm going to leave this down here. We remind us, for anyone who wasn't here, or just to blow our mind again, like what was 1/7? Yeah, go ahead, Lane.
14, 28, 57.
Then this is where it gets difficult, and that whole thing repeats. What was 2/7? I don't even know. Dr. Chalice may not know this. This is like mind-blowing. Whitney, what was 2/7?
28, 57, 14.
And it keeps going using the same set of numbers in the same order all the way through. So, class answer, what would be the first decimal digit of 3/7? Anybody?
5.
Ooh, so we've got some discrepancy. We've used our 1, we've used our 2. What would be the next biggest value? Because, and you maybe didn't realize this yesterday, there are 1, 2, 3, 4, 5, 6 options up here, and there are 6 fractions of sevenths. 1, 2, 3, 4, 5, 6. Once you get to 7/7, you've got 1. So my first value here, Jeremiah, I think I heard you say it, is going to be 4 because it has to be the next biggest number. So then it'll be 4, 2, 8, 5, 7, 1, and all of that repeats. Then we keep going on. The next one will start with the 5, the next one will start with the 7, and the next one will start with the 8.
That's the only number that can do that.
Don't know. It's the one that I know most specifically. It might happen somewhere else, so I'm not going to tell you no. But this is the one that I know of distinctly, uses the same digits in the same order, repeating that set of numbers. So go ahead and grab out those 6.2 notes. We are going to shift gears. Yeah. What's up?
About the last question.
Yeah.
So since it was 6.4 inches and
Yeah, sorry, we never did answer. Since it was 6.41666 forever, which is bigger, the cave or the submarine itself, Anish?
I was gonna say I put it different ways with the decimal way.
Okay. But, so we did the decimal way. So since we did the decimal way, based on that, which is bigger, Elena?
The submarine.
The submarine, right? Because if we compare a 6.4-inch wide cave to the 6.41666 forever, this will not fit. So if you're looking for the answer of will it fit, that would just be no.
I'd be so scared to go on a submarine.
Yeah, the pressure is what's scary to me.
Because it can break the glass.
It can break you.
Yeah, exactly.
Now it's going to capture. Oh.
I would only.
Guys, don't worry. I put on one of my professional growth goals that I need new hardware. There we go. Maybe. So go ahead and write out your long division expansion of 3/4. Your division there, 3 divided by 4, while my computer decides if it's going to cooperate or not. Where is smart?
Where are the notes
For today, vertically in the little thing. I handed them out when people walked in, but if you got in late.
Oh, I didn't.
There we go. Here. They're always right.
In the middle.
Accelerated 7.
Yeah.
This guy. So many of us should know 3/4 or 3/4 because it's something that we've been using for a very long time, and ever since your parents have been giving you allowance, you've probably dealt with quarters. So when we talk about fractions, whenever I have a denominator of 4, we're talking about quarters. And if you have 3/4, how much money do you have? 75 cents, right? So we know that this is going to become 75 cents. Are there any decimal values after the 5?
No.
Well,
Yeah.
okay, so this is kind of a trick question. Because are there any numbers with value? The answer is no. But are there any values out here? Well, yeah, tenths, hundredths, there's a thousandths, there's a 10,000ths and a 100,000ths. And have you ever actually really looked at the price of gas?
Yes.
And probably not because you don't drive. But if anyone's ever really looked at the price of gas, like the other day I got gas for $1.91. But it wasn't actually $1.91. Anyone know what the price would have actually been? Sam? $1.91. And then on the sign, a lot of times I'll have a little 9. But please don't be an exponent. If that's an exponent, we'd be in big trouble. That is really a 9 in the thousandths place. But money doesn't have a thousandths place. So what are they actually doing here? Sean?
Rounding up the number?
Yeah, they know that no one really pays attention to this number because it doesn't really exist when we deal with money. But on the cash register, it exists. You're paying $1.91 and 9/10 of a penny on every single gallon. So this is an example of a terminating decimal where most people don't even pay attention to this decimal value because they don't think about it. Our currency only goes 2 decimal places. They're pulling a trick on you. And think about every person getting gas. Every single gallon at every single gas station all over America getting that extra penny. It adds up in pretty big ways. Julian?
So would it actually be $1.92 or
Not quite, because it's just below that. But if we wanted to approximate, yes, it's essentially $1.92. So watch now, when you go past a gas station, look for it, whether it's a digital sign or a real sign. It's got that little 9. And I hate when they have it little and it's raised up because it looks like an exponent, and that's wrong also. Jeremiah?
How many gallons did you do?
My tank takes like 12. if it's empty. So our decimal expansion here, we should have had the zeros that we added on. But what we see is that we eventually get a remainder of what? 0. So a terminating decimal ends with a remainder of 0, and that tells me that it terminates. So not the Terminator as in our robot dude that comes back to save us all from, I forget exactly the plot of that movie, but terminating as in it ends. It has an expansion that stops in zeros. So these are your ones in the numerator. So 1/2, 1/3, 1/4, 5th, 6th. We did sevenths already. That's why the 7th is not on here. 8th, 9th, and 10th. Now, why do you think I might give you the 1 numerator form of all these values? Like, what if I then asked you to find me 3/8? Ellie?
Because then you can multiply and figure out what the outcome will be.
Yeah, so use this chart to multiply. So if I know 1/8, 3/8 is really going to be 3 times whatever my 1/8 is. So guys, I would write this example if I was you. Because I already know what the 1/8 is, and you can put a little 1/8 above here. So why I gave you this table is to save you time and save you effort. If you memorize the ones, like 1/2, 1/3, 1/4, 1/5, you can then just take those and multiply up to find any fraction that you need. So if I multiply 125 by 3, what do I get? Forget about the decimal place, just 125 times 3.
375.
375. So this decimal expansion, when I put the decimal places back in, just tells me that 3/8 is 375 thousandths. Does this make sense? Any questions? Jeremiah?
Back to the gas. Why did they make it super small? They should make it. They should.
So people don't pay attention to it. But even if you did pay attention to it, you can't do anything about it. Like, if you have a problem with it, go to a different gas station.
Is every gas
That's like
station
supply and demand. Yeah. At least if you find one that doesn't, go check the pump. Like if it doesn't say it on the sign, go check at the pump. I've never seen a pump that doesn't go to the 3rd decimal place. It's just something they decided to do, I guess. Yeah.
Does it change from 9?
No, I've always seen it as a 9 at the end. Because essentially they just want that extra penny.
I've seen that.
Yeah. So we got to keep moving on. We are running out of time quickly. Last thing, real quick.
They should do 99 instead of just 9 because 9 is just 90. And then
Well, if it's 99, people might start paying attention to it then. So I want you guys, just from your brain, what fraction decimals do you know that you know both of them? Because this was actually on the SLO, and I think a lot of us misunderstood this. We want to be able to talk about rational numbers in both their fraction form and decimal form. So from your brain, what fraction to decimal do you know that terminate? Like a very common example. I know 1/2 becomes 0.5 and it ends. There are no decimals beyond that. What fractions do you know that are not terminating? Now this could be repeating or it could be not repeating. So this is an example of repeating, but you could also use examples that are not repeating. I'll show you in a second. There's only a few. Those are more difficult numbers. So try to get 3 examples for each category. Do you need a pencil?
Yeah.
So you are always more than welcome to ask me. I've got tons of supplies.
Are we allowed to use your examples?
I'd encourage you to try to have 3 on top of those examples, because those are pretty common, pretty well known. You are welcome.
Can we do like 1/4 and 3/4?
Wow.
Would that be
Yeah, but if you use the ones from the table up there, it's kind of lame. I mean, you can, but I'd love for you to try harder than that.
Wait, are we allowed to use fractions on t-shirts?
Okay. Or a huge number.
Yeah.
So I always intro every lesson with just kind of like a start slide to get them into every day when they're in class. They talk about it first. So there's normally some kind of picture or something that gets them interested in talking about it and like activity. But actually today, and this has been the theme this year, we had to finish up things from the lesson previous, from yesterday. So then we go into today's lesson. Then as we progress through, I really try to alternate. Let me show you the skill and let's discuss it together, and then let's have you try it. It's like right now, students are going to try it on their own schedule. It's probably a little impatient because they're probably about ready for me. Any volunteers to go to the board and show a couple of theirs? Yeah, Andrew, can you go up? Hey, can you catch, dude? Andrew. Bad toss. That was my bad.
Are you sure about that? Are you sure about that?
So I had interest in that actually all the way back in college. I went to Auburn University, and the first experience we blended was physics course, which was really interesting to see how the statistics when there's so much data research that doesn't need to be done in the physical classroom. So it was really good that students had the time to work together outside of the classroom. And really that whole electronic attitude of anybody can learn anything, anywhere in the world, as long as they have internet connection, and you want to try to do it for free. Anybody have other examples that want to go up? Sam and then Dom, and that's probably good then. So my start actually was at Auburn University, and we had a blended
Change your color. Oh, crap.
every seed, let alone been able to take too strong. Really do these problems outside of class and learn what we can do. So we have these a group of nerds in the math lab that we work together. It's like 10 at night and it doesn't matter. You don't need it.
I forgot math was dang.
Math is really interesting. A new generation of students teach now. I can give them the access to be more prone to learn when they want to learn. Because they may not want to learn at 9 o'clock in the class. But if they can learn at home and they have the ability, it works out well.
Oh man.
So we're just still getting into it.
Use the eraser.
I got your pencil now.
Put down the
No, I got the
and
pencil.
I've got a challenge. I've had students who've been blocking multiple hours working on one at a time that I haven't even necessarily said you need to do this, just here it is available. Other students kind of have
Oh, that's wrong. No.
because of this, I have no idea where it's everything that's going on. There's not this like, there's a real something we don't know how it is, or we're waiting for it to run a report, and I was actually just discussing it. I shall not watch anybody win. Active, current, everything that we do. Parents know what's going on. They know what's going on. Find materials. Well, here's where they can access things in the on
That's not just like a boss. You're all about to get your minds blown.
I think it's helpful not only for the students but also for the parents. Yeah, thank you. All right, do we agree with these or do we have any discrepancies? Yeah, we agree. We got 8 9s, 2 18ths. Now, what would 2 18ths be in reduced form?
1/9.
1/9, right? And 9 11ths. How did we then get from the 9 to the repeating 81? Who put up their 9 11ths? Who was that? Sam, how'd you get to the repeating form there?
I multiplied 9 by 9.
Yeah, you multiply that numerator by 9. Now, what if, just to remind us of rules from yesterday, what if we had, still in the non-terminating section, let's say 7 9ths? How do we treat the 9ths? You said for the 11ths, we multiply by 9. For the 9s, Whitney?
You multiply by 11?
Yeah, we multiply the numerator by 11, and we get that the 7 is going to repeat forever. And you can put the bar over 1 or 2 of them. Jeremiah?
Do you know what 3 divided by 10 is?
Yeah.
What is it?
3/10. Is this some joke?
Or no, I mean 10 divided by 30. I meant to say 10 divided by 30.
I was very confused. Like, is this a setup? 10 divided by 3? 3 1/3?
Just a prank, bro.
Or do you want the repeat? Like, what do you mean?
Those are good cameras.
Yeah. Hold on. I think Jeremiah is trying to make some connection that I'm lost on. Hey. Shh.
It repeats over and over and over.
Yeah. Because it's just like 3 1/3. Are you trying to like make some big connection, or are we just talking in circles? Okay, I'm confused. So I think there's something I'm not getting. Which of these are terminating?
Wait.
So actually, let's use cards. So
Yeah, we don't have that. We don't have that.
what?
That's not on there.
We don't have that.
Wait, no,
You got the wrong version. That's fine.
We said
Apparently that got chopped off this copy.
now we don't have
No, wait.
And we don't have the example.
So
But wait, there's
Holy
more.
crap.
we can write things down.
Can't wait.
Is
Okay.
Just prank phone.
we ready?
Yes, sir.
'Cause I can wait. Is 407 a terminating decimal? Now that brings up the question, 407 doesn't show a decimal. So is every number a decimal number? Andrew?
Yeah, it is a terminating decimal because it just has 0.000. It's an actual value.
So we look back to the definition, is what Andrew said. It has 000 at the. So the definition says it ends in zeros. So if I think about 407, what you really need to write on your paper is it has a decimal, even if we don't show it, and it actually has zeros forever, and the zeros actually repeat. But if it repeats zeros, it doesn't mean anything. You got this down, Saul?
Yeah.
So don't say yeah when it's not on your paper yet. Write it down. So this example, sorry I got chopped off your copy, and it might actually be on the back page, because sometimes I shift things around when I send it to the copy.
Nope.
Also, that back page.
All you need to care about is the number 1 3/4, and then the number 3 7/8, which actually, the table on the back is where we're just going to put a bunch of fraction decimal equivalencies. So if you just want to put these in the table, you can. If we did 1 3/4 and I place this on the digital scale, is a digital scale going to read out in fractions?
No.
No, because it's digital, right? So it's going to give me the decimal value. Now, we already talked about 3/4. So what would 1 3/4? Well, we know the and. The and is where I break. What am I breaking between? What does the and separate? Jeremiah?
The whole number in the decimal.
Yeah, but we want to say the whole and the partials. Because I can read this as 1 3/4. So I don't need decimals for the and. And when people say the and is the decimal, that's not quite right. It breaks the whole and the partial values. So what is the partial value that represents 3/4 in decimal form? We already have, 75, right? 75 hundredths or 75 cents. So this would be 1.75 LBS. And did we talk about LBS in here yesterday?
Yeah.
Where LBS came from?
Libra.
Libras, right? So it goes back to a way long time ago when we used Libras. Now 7/8. 7/8 is a tough one. Now we know we're going to have 3 and a decimal, but 7/8. How could I figure out 7/8 without a calculator? Sam?
You can use your chart on the top.
I can use my chart. So if I know that 1/8 is 0.125, I know that 7/8 will just be 7 times the 125 thousandths.
That's a little cheating way.
So break this apart. What's 7 times 100? 700, right? That's easy.
Can I get the answer?
We're working towards it. Then what's 7? Now we could break the 20 and the 5, but what if we do it together? If you have 7 quarters, how much money do you have?
You have 7.
$1.75, right? So 175, and in total I get 875 thousandths, and I bring that back down, and that would be my value. Any questions on how I took my 1/8 and got 7/8 by just multiplying it. All right, flip on to the back. I want you guys on your own or with a partner next to you. No getting up and moving, but you can talk with somebody close to you. Figure out, now hold up, figure out the reduced fraction form of this rational value. So one thing I will remind you is every decimal number, when read properly, puts itself into fraction form. So this would not be 7.125. That's not how you read it properly. So be careful. Think about how would we read it properly, what fraction does that create, and then how do we reduce. If you are stuck, raise a hand.
They're all 7.
Yeah, like 48. Yeah, so that one today, this is the accelerated side of class. We're actually looking through the content really fast. Still can't keep up. So when the math side comes in, they are a lesson video from this class. Just a thought about it. Kind of giving what this thing is when I really release you guys. And then, so as they do that,
Oh, I think I know what that is. No idea. Oh wait, so there's one part here that always has right.
we are converting these to fractions. How does it help when you guys are working together?
Because like we can like express ideas from one another and the other one could express the ideas to help the other one understand. Okay, next one.
One more time, look at her and tell her.
Okay, so you don't understand something when you're working with someone. You can express your ideas to the other.
All right, let's bring it back for a second. When we start talking about these values, if we read them properly, the digits in the decimal tell me the numerator of the fraction. But how do I know the denominator? So, Dom, with 7 and 125, how do you finish reading that? That'd be 7 and 125 thousandths, which puts 1,000 in the bottom. Then when we go to reduce, what did you realize that 125 and 1,000 could both be divided by?
8.
Bigger.
Well, not 8. I did this awkwardly because I screwed it up. I thought I put 7 in 1/8 because I thought we were figuring out the decimal in order to be a fraction. That's what we're doing.
We are, but so you immediately recognize that 0.125 or 125 thousandths is 1/8. You're right. Now the other thing we could do here,
You can get it by 25, and 25,000 divided by 25 is 40, and then that's 5 for 125, and then that can be reduced to by 5 to 1/8.
so we could have actually divided 1,000 by 125, but because that isn't as obvious to us, it's totally perfect to work through it just like that. You can divide by 25 first, and then divide by 5 next. Solomon, what about the next one? 7.28, but that's not how we say it properly. How do we say it properly?
We can apply this one.
So, just to say this properly, 7 and, what would you call that decimal?
I honestly.
So that'd be 7 and 28. What's the second?
28
Hundredths, right? Because we have the tenths place and then the hundredth place. So that tells me 28 hundredths. So please make sure you get this written down if you guys couldn't figure that out. Now I look for what they can both be divided by, a common factor between them. So 28 and 100, Jeremiah?
2.
Yeah, they're both even. So I could think harder and try a bigger number, or I could just do 2. And I might have to do it a couple times.
Lazies.
But 7 and 14 over 50. Hey, look, they're both still even. I can divide by 2 again. 7 and 7 25ths.
These are lazies.
And then we are stuck. The 7 is prime, so we are done. We get 7 and 7 25ths. Now 7.5, that is not how we say it properly. So, Whitney, you able to help me there?
It's 7 and 5/10.
7 and 5/10. What could 5 and 10 both be divided by?
2. So
Ooh, wait.
or,
5 can
no,
divide
not
by...
5.
Ah, I
That
see
would
what
be
you're thinking, though.
1.5.
That's where the 2 got into your brain. So we get 7.5. And then our last one here. So just like you said, the 0.5 was 5/10. Ashley, what about 7.6? How do we say that properly? 6/10. What can 6 and 10 both be divided by? Yeah, and that becomes 7 and 3/5. Sorry, that one's a little bit harder to see. We will wrap all this up and then dive into our lesson on percents tomorrow. Well, no. Tomorrow I think we'll probably... Do you guys need a review game for the Chapter 5 test? Or can we- All right, we'll at least play a review game for like half a period. I don't know if I'll do the whole period, but at least half the period. All right, guys, have a great day. Your homework is already live. Sorry that I forgot to make it live yesterday. 6-2 is live, yep. Yep, no, 2 days. You always have 2 business days.
I like how you say
Business days. It's business days. It's days that we are operating in business.
restaurant days.